Today we're going to go over a quick problem called find the length of the largest contiguous subarray in a binary array with an equal number of ones and zeros. Alright, that's a mouthful. We're going to do, so basically we've got this array here. It's going to have a whole bunch of zeros and ones in it, and we want to find a subarray with equal numbers of zeros and ones. Like in this one, we have 0, 1, 0, 1, 1. The longest contiguous subarray is 4 because we have 0, 1, 0, 1, equal number of zeros and ones. Alright, just like with a lot of problems like this, there's a trick, so you really want to just sit down and think about it before you start doing anything coding wise or writing wise. And so what's unique about an array with equal numbers of ones and zeros? I didn't get this right away, but I guess any kind of binary, if you have a whole bunch of binary things, one and the other, then if you add them all together, they'll cancel each other out. So if you consider, instead of calling 0, 0, you call it negative 1. If you add up these, negative 1, 1, negative 1, 1, you have a sum of 0. So how do we do this problem then? Basically, it becomes a lot easier once you realize that you can add them up and you're looking for a sum of 0. So what you'll be looking for is a spot in this array that's kind of flat. There's a chunk in there that just cancels itself out. So what you can do is you can go along and sum them up, create a second array, which will start at 0, and then go through and sum them up. So we're calling 0 negative 1, so the sum of that is, you just keep a running total, negative 1, and then you add in 1, so it's 0, and then another negative 1, it's negative 1, and then 1 is 0, and then 1 is 1. Now what we're looking for is a block that just has canceled itself out. So what we're looking for is a sum that hasn't moved. So let's say between this 0 and this 0 that hasn't moved, so that's our block of 0, 1 that canceled itself out. Or between this negative 1 and this negative 1, that sum hasn't moved, so that's between the 1 and the 1. Okay, because we start at 0. That's before we hit any numbers, and then we add on to that. Okay, so now what we gotta do is find the two equivalent numbers that are equivalent sums that are the furthest apart. In this case, it's this 0 and this 0. And so that is 0, 1, 2, 3, our index of 4, and our index of 0. So our length is going to be the right index minus left index. So we have a length equal to 4. Okay, so now we know what we're looking for. Our goal is to sum these up, keep a running total on an array, and then look for the two sums in the array that are the furthest apart and are equal. And then we can take that right sum, subtract our index of the right sum, subtract the index of the left sum, and we get our length. Okay, so how do we run? It's pretty easy to do on paper, but how do we do it if we're doing it with code? We're going to use a hash table. So start making hash on the bottom here, and what you do is you're just going to go through, and every time you hit a number, you're going to write down you're going to index that number, so 0, and then we're going to index it with, if it's the first time we use it, we're going to put down first, and then write that index, so that index is 0, and then on our max, our max, which is our length. That'll be, in this case, 0 because we just started. Okay, so we're going to hit our second hash here, -1. Same thing. First, 0, max, 0. Alright, now we're back to 0. So we just go here. First is still 0, and our max is going to be 0, 1, 2. It's going to be 2 minus our first. We've kept track of the first here. So our current minus our first. So that's 2. So that's saying if you look through here and you find the max, then it's saying our max subarray right here is of length 2, so that's that 0 and the -1. They have equal. Okay, let's go to the next -1. So that becomes current is 0, 1, 2, 3, and our first was actually at 1, so our max is 2. Okay, now let's see, that was our second -1. We're going to hit a 0 now. So our first was at 0. Our current is at 0, 1, 2, 3, 4. So our max is going to be 4. Alright, and then we hit a 1. So our first is at 5. And our max is 0. Alright, now all you'd have to do is iterate through here and find the biggest max. And that's your length of the array. If you want to actually find the subarray, you just iterate through, find the largest max, and take your first. That's gonna be your, that plus 1 is your left index. Because again, we started at 0, which is outside of here, but that's just our base, so we level out back to 0. And then your the right side of your subarray is gonna be your first plus your max. Alright, okay, so now running time for this. Let's see. So we gotta run through it, and so we go through it in n, and we gotta sum it up. So this part takes big O of n, actually theta and everything n, so because we're gonna go through it n times no matter what. And then this hash part, we're going to, at most we're gonna have to have a space of n. That's if each one of these values is different. Our maximum space is n, and then for that last step where you have to go through and find the max, it's going to be big O of n again, because your maximum number of items in your hash table is going to be n. So we're looking at overall big O time of linear time, just n, which is awesome. Alright, as usual, I'll put the code in the comments. I think it's a lot better to just look at how these are done and then code it later, because once you figure it out, it's a lot easier to code it up. Alright, check out the comments.